In this week's episode, we're going to be taking a look at the Ring Nebula, an object with a ton of ringing endorsements. This is the picture in 1,000 words. In this episode, we're taking a look at the Ring Nebula. It's a classic astronomical object. It's not too far away from us. It's been taken a look at by astronomers for centuries at this point, and the Hubble Space Telescope has taken an exquisite series of images of it. So let's dive right in. So this is the Ring Nebula. This is about 2,000 light years away from us. And the diameter of this thing, of this gorgeous ring that we're seeing here, is about 1/30th of a degree on the size. And that's roughly a little larger than the smallest things that the human unaided eye would be able to make out. And so we can basically, if you take a look at this without a telescope, you can see that it's not just a star. It looks a little fuzzier than that. And that's one of the reasons why it's called a nebula. That just means fuzzy object. But at the distance of 2,000 light years, this is approximately 1 light year in size. That's about the distance between us and our closest stellar neighbor other than the sun. So this nebula has actually grown pretty large. So this entire region is called a planetary nebula. There are a bunch of them that we've seen. This is one of our most prominent and beautiful ones that we can take a look at. And what we mean by that, it's actually a kind of misnomer. It has nothing to do with planets. What astronomers that took a look at this originally, because it's slightly larger than our eyes can see, you can, in the night sky, tell that it's not quite a star, that it's actually probably just a little fuzzier and it looks a little bit more like a planet, much like Jupiter. And so that's where it got its name from, is that it looks like a planet, and so therefore we call them planetary nebulae. So this image, it's a real color image. It is taken with a camera that can see the same visible light that our eyes can see, but it's taken with some special filters, rose-colored glasses, if you will, that are looking at very specific elements. For instance, the blue that you're seeing here is only the light produced by helium. The green that you're seeing here is only the light that's being produced by oxygen. And the red that we're seeing here is only the light that's being produced by nitrogen. And this is done for a specific reason. It's because we want to see most of the light that's coming out of this nebula is coming out from these elements. And remembering that when the way that all of these pictures work, much like your screen that you're watching this on, the primary colors of this are red, green, and blue. And so the red and the green, when they match together, you get a little bit of this yellowy stuff. So that is light that is coming both from oxygen and nitrogen at the same time. So we're seeing this object face on. And what that means is if you took a look at this object, it'd look a little bit, we're looking at it face on, but if you looked at the side, it would look a little bit like a donut, and we're kind of looking at it right over here. And so all of this light over here, that's this stuff and this stuff, all of the way around. And all of that blue light, that is going to be sort of in that central region. It's all of this stuff is the blue light. So the key thing to understanding this entire image is by taking a look at the central source from where it all comes. And so let's zoom right in right over here. And what we're seeing right over here, that is the central star. So this is no longer actually a normal burning star, but at once upon a time it was. And what this star was is just a normal kind of, a run-of-the-mill star, a little larger, maybe about 3 times the mass of our sun. And a star like that, it's not super big. When it dies, it doesn't go supernova. Our sun's not going to go supernova. But inside every star, you have a core. So all the layers of gas, primarily hydrogen, but some helium, are being held up by the energy that's being produced by this core. And what's happening in the core is that you have a large amount of nuclear fusion that's going on, and it's turning hydrogen into helium. This is what's happening actively in our sun right now. And the heat that's being produced from that and the energy that's being produced from taking hydrogen and turning it into helium, that is keeping all the layers of the sun supported. But there's a point where you run out of hydrogen and you can't burn that anymore. And bigger stars will then go on and try to burn off the helium and burn into the rest of the elements. But at some point it stops. There's not enough material to keep it compact and keep it really hot. And so what happens at that point is a lot of this stuff starts to blow away, and all of this gas is starting to disperse out. And that is what we're seeing here. We are seeing gas that is being released from the outer layers of the star. In particular, what we're seeing is things like the helium gas, the nitrogen gas, and the oxygen gas that are making its way out from the central star. So why all the pretty colors? When you take a look at the nitrogen in the air, it's not emitting a lot of color, right? It's basically transparent. Well, what's happening is what you're left over with is this core. This core on its own just kind of lives off, and this is called a white dwarf. And this white dwarf, all it does is it's really hot, and it's just going to sit around and radiate energy out. And that's what we're seeing it do, and it's just radiating energy out. If we zoomed in again, it looks fairly white because it's producing a lot of light in all of the primary colors in red, green, and blue. But the vast majority of the light that it's producing is coming in the ultraviolet. And so it is producing ultraviolet light. This is light that is bluer than our eyes can see and has a lot of energy, and it's heating everything up. First of all, it hits all the helium, and this stuff is getting lit up, much like a fluorescent bulb would get lit up. And then it's getting into starting the oxygen. The oxygen's a little cooler, it's a little further away. It doesn't get as much of the light. And so what we're seeing there in all this green stuff over here is the oxygen that's glowing. As we get further over, we get to the nitrogen. The nitrogen is the coolest of all in all of this gas. And the other thing that's happening is all of this gas, because it's been blown out, it's flying away, and it's flying away at a pretty fast speed. It's moving something like 20 kilometers every second, not hour, every second is moved. So if we wait a second, it'll have moved another 20 kilometers. The reason that we don't see, it moving in real time is because it's just so far away. So what's going to happen to this entire region? As the gas starts to move further and further out, remember, this stuff is moving at around 20 kilometers every second. It's going to expand, and all of this stuff is going to get further and further away from that central star. And as it gets further and further away from that central star, it's going to be collecting less of the light that's being produced from it. And as it collects less and less of the light that's being produced from it, all of this stuff will start getting much, much dimmer. Eventually, it's going to get to the point in about 10,000 years or so where all of this basically looks like all of the gas around it. It'll start to look transparent, and we won't be able to see it as this bright, beautiful ring anymore. But at that point, all of the elements that were produced in it, so all of the helium, all of the nitrogen, all of the oxygen, all of that is going to go in and enrich the gas that surrounds and enrich all the gas that is in our galaxy. In fact, through stars like these, because there are billions of stars like this in our Milky Way, this is how most of those elements end up making it into other stars, into the gas that forms those other stars, and eventually into planets and potentially creatures like you or me. So what we're seeing here is how we're producing the elements that made us up. And the elements that are in us today, the air that we're breathing, a lot of them used to be lit up like one of these planetary nebula that we've seen. That's all we have time for in this episode of A Picture in 1,000 Words. The Ring Nebula is a fun one because it's something that's bright enough that your local astronomy club or the telescope at your local university can probably see it. So if they have a public viewing night, definitely go take a look. It is incredible to see with your own naked eye for the first time. Be sure to like, comment, subscribe, show us some love. We'd love suggestions for any objects that you want us to take a look at in future episodes. And your fun fact for this week is that originally when astronomers took a look at the blue light that was coming from planetary nebulas like the Ring Nebula, they didn't quite know what element that light was coming from, so they called it nebula. Turns out it was helium all along. Until next time.